Now, consider a tetragonal crystal. Why I am choosing tetragonal crystal is because some of the examples that I gave of materials which show piezoelectric behavior, such as barium titanate, lead zirconate titanate, they also have a tetragonal crystal structure with the space group P4mm. So, tetragonal crystal system. Let us put the 4-fold axis parallel to the x3 axis. So, I have x1, x2, x3 and there is a 4-fold parallel to the x3 axis. See, if I do a 4-fold means I will do a rotation of 90 degrees. As a result, x1 prime will coincide with x2, x2 prime would be opposite to x1, while x3 prime will coincide with x3. And we have seen this in the discussion for second rank tensor. So, I will not dwell on how do I get this direction cosine matrix. You can go back to that lecture if there is some confusion. 0 1 0 minus 1 0 0 0 0 1. This is the direction cosine matrix. D prime I j k. Let us see how the piezoelectric tensor transforms. So, I will just repeat that equation once more. A I L A J M A K N D L M N. Let us calculate a few components. D prime I j k. So, let me write it for some specific values for I j k. So, D prime let us say 1 1 1 equals A 1 2, only the non-zero, there will be only one term A 1 2, A 1 2, all the 3 terms are 1. If you look at the direction cosine matrix multiplied by D 2 2 2, and then this clearly is simply D 2 2 2 because A 1 2 is 1. Let us take how the D 2 2 2 transforms. So, D prime 2 2 2 is A 2 1, A 2 1, A 2 1, only non-zero terms, D 1 1 1. This is minus 1 and minus 1, hence I will get this as minus D 1 1. Clearly, the result of this would be that D 1 1 equals D 2 2 equals 0. This is because if I do a rotation of basically 90 degrees, the tensor must remain unchanged, and the only way that is possible with the kind of result I have got is both the components have to go to 0. Let us also calculate for D prime 3 3 3. Now, this is A 3 1, A 3 1, A 3 1, D 1 1 1, or rather no, this is not A 3 1, sorry, this is A 3 3, A 3 3, A 3 3, D 3 3, which is equal to D. So, this will be non-zero. So, this term will survive. Similarly, if I look at D prime 1 2 3, this would be A 1 2, which is plus 1, A 2 1, which is minus 1, and A 3 1, which is again plus 1, and this is equal to D 2 1 3. and this is minus D213. D prime 113, and now I am not going to write all the terms, but D113 is equal to D223. Similarly, D311 equals D322, and everything else is actually going to be 0. So, the final piezoelectric matrix that will look like in the reduced coordinate system. So, which means that just for reference, D11 is going to be actually D11 in the reduced matrix. This will be D22 in the reduced matrix, and this D33 would be D33 with 2 indices. Similarly, D123 is D prime 1, this is D14, this would be D15, and this minus D213, this is going to be D25, and this is going to be D24. So, all you have to do is come to this and find out how the indices change. So, now if I write down this thing, now I am going to write it using a notation that is given in Nye's book. I am going to use that notation because that is a very simple way of writing this rather than writing each numbers. So, let me first write down the matrix. Now, what does this mean? If you see a dot, that means that component is 0. If you see either a filled circle, either green or red, then this is non-zero. If you see two filled circles joined together and same color, then the two components are equal. So, equal components. If one sees components joined with different colors, then the two components are equal but of opposite sign. Now, suppose in addition to this fourfold, I now add a mirror, a vertical mirror. Go back to the point group discussion in earlier lecture to understand what do I mean by a vertical mirror? Well, vertical mirror is simply that it will contain the four-fold axis. So, I have a four-fold rotation axis here. At the same time, x2, x3 plane is a mirror plane. If I add a mirror like this, the point group that I will get would be 4 mm. Now, let us see what the mirror will do. Mirror will take this x1 axis, reflect it in the opposite direction, making it x1 prime, while x2 and x3 are in the mirror plane, so they will coincide. So, x2 will coincide with x2 prime and x3 prime will coincide with x3. As a result, the direction cosine matrix becomes -1, 0, 0, 0, 1, 0, 0, 0, 1. And let me take just one component. What will happen to that one particular component? Let me take d prime 1, 2, 3. Now, d prime 1, 2, 3 in the reduced notation it is d prime 1, 4. So, I am taking this component Where is this located in the piezoelectric component matrix? 1, 4. So, 1, 4 is located here. So, this is D 1, 4 or D 1, 2, 3. So, let us see what happens to D 1, 2, 3. So, D 1, 2, 3 transforms to D prime 1, 2, 3, and let us put what are the 3 numbers we will get from the direction cosine matrix which are non-zero. It will be A12, A21, A33 into D123. This is equal to A12 is -1, A21 is +1 and A33 is again +1, D123. Clearly, this is going to be minus D123. So, for this tensor to remain unchanged on reflection, when the reflection plane is an x2, x3 plane, D123 has to go to 0. Now, if D123 goes to 0, here we already have D prime 1, 2, 3 because of the 4-fold rotation was D213. So, therefore, D213 will also go to 0. And what is D213? D213 in the reduced notation is D25. And where is this D25? Well, this is D25 or D213. So, both of these, this one will go to 0, this one will go to 0, and if we do for other things, we will find that everything else will remain as it is, and hence the piezoelectric matrix now will look like so. this one is D311, D322, D333, and I have this is D123 and D113. So, D311 equals D322 and these two are also equal. So, there are only three independent components, and even in that this D33 or D333, this D33 is the important modulus. Why is it important? Well, in this gas lighter example, when I push the trigger, it actually compresses the piezoelectric crystal. So, it is compressing it in the x3 direction in a uniaxial mode, and therefore, the modulus D33 becomes important and others are not as important, the other two components in this tensor. So, therefore, if you take a material with this kind of basically space group or point group 4 mm, one has to look at the D33 modulus to see whether for the particular application you want to use that material, is that D33 high enough. With this, I close the lecture. Thank you.